Welcome to another episode of Saltwater Stories. Hope you're ready for this week's story. Because, wow, this one has an incredible amount of mystery and intrigue.
It really does. We are traveling somewhere very, very special today.
We are. We're going to the darkest, most mysterious part of the ocean. It's a world, full of glowing creatures and secrets hidden deep below the waves.
It's a kingdom hidden from sunlight. And the creature we're looking for today is so grand, so strange, that for hundreds of years, people thought it wasn't a fish at all.
They thought it was a monster.
Exactly.
A monster.
So to really get this, let's travel back in time. Way back. Imagine it's the 1700s. The ocean's this giant unexplored map.
Right. And you're a sailor on a tiny wooden ship miles and miles from shore.
And the weather is terrible, waves are crashing high, and then all of a sudden something enormous and strange flashes right past your boat.
And these sailors, they didn't have cameras, right? No science books to tell them what they were seeing. Their minds immediately went to dragons and sea serpents. Of course.
Yeah.
They had to explain these bizarre sights of what they knew, and what they knew was mostly myths and legends.
We actually have an amazing account from 1741. It's from a missionary named Hans Egede.
Oh, what did he see?
He described seeing a terrible sea creature. And it was massive, coiled in the water, and he said it was, and this is a quote, longer than our whole ship.
Longer than the ship? Can you even imagine that? A giant snake-like animal, bigger than your house right next to your little boat.
Terrifying. And other stories started popping up describing these 50-foot-long sea snakes with these fantastic flowing red manes.
So they were instantly labeled sea serpents.
Yep. The unknown always looks like a monster until you shine a light on it.
Well, today we are shining that light.
Yeah.
Because that monster, it wasn't a monster at all.
Not even close.
It was a real, amazing, incredible fish. Today, we are opening the secret scientific address book to uncover the true story of the world's longest bony fish, the oarfish.
We're going on a special exploration into the deep, using these ancient stories and some really cool modern science to understand this ghost of the ocean.
Our mission today is to figure out exactly how this incredible creature survives in a place that should totally crush and freeze it.
And how it managed to become the most famous sea serpent in history.
Okay, let's start with the facts. This is a very kingly fish. Its scientific name is Regalicus glesne, which sounds super grand.
It does. And it has a world record to go with that grand name.
It does. What's the record?
The giant oarfish holds the official Guinness World Record for the longest bony fish in the entire world.
Okay, you said bony fish. Why is that word bony so important?
Well, it's a great question because it tells us what its skeleton is made of. When you think of a giant of the sea, you probably think of a shark, right?
Yeah, totally.
But sharks have skeletons made of cartilage. You know, that soft, bendy stuff in your ears and at the tip of your nose? The oarfish, though, has a skeleton made of hard calcium bone, just like a salmon or, like us.
And it is huge. If you put it next to other bony fish, what would that look like?
Oh, it would look like a piece of spaghetti next to a tiny pea. It can grow longer than a giraffe is tall. Or even longer than two big family cars parked end to end.
So how long are we talking exactly?
Well, the ones we can confirm are usually around 26 feet long, which is already massive.
Already huge.
But those old sailor stories and unverified rumors, scientists think they might actually be true. They claim the oarfish can reach up to 17 meters.
17 meters? What's that in feet?
That's almost 56 feet long.
No way, 56 feet. That's longer than a school bus.
Longer than a school bus. It's the size of a legend, and its body shape is just as strange as its length.
Right, because it's not round like a snake, is it?
Not at all. It's what we call laterally compressed.
Laterally compressed.
Yeah, it just means if you look at it from the front, it's super, super thin, like a ribbon. Or like a party streamer that's been stretched way out, flat and long.
And it looks like a giant shimmering mirror. How does it get that incredible silver color?
That's one of his coolest tricks. Instead of normal scales, like a goldfish, the oarfish is covered in these tiny, shiny crystals made of something called guanine.
Guanine.
Guanine. When light hits these crystals, the fish just shimmers like polished silver. And this is really important for camouflage in the deep ocean. It helps it blend in with the faint blue light.
It's like a mirror shield, but the part that really scared the sailors, the thing that turned it into a sea dragon, that's its head, right? It has this spectacular crown.
It really does. That's its dorsal fin, the fin that runs along its back. But on the oarfish, this fin runs the entire length of its body, from its nose all the way to its tail.
The whole way.
The whole way. And right at the front, on its head, the first few fin rays are incredibly long and bright, fiery pink or red. It looks like a flowing crown.
Like a majestic, sprightly crest.
Exactly. And that's actually why fishermen hundreds of years ago in Norway gave it the nickname the King of the Herrings.
The king of the herrings. I love that.
They believed this magnificent crowned fish was literally leading the huge schools of herring to their boats.
And the scientific name, Regalicus, that means royal, doesn't it?
It does. It comes from the Latin word for royal.
Ah.
So even the first scientists who saw it knew this fish was something special.
So if we go back to our ingredients for a sea serpent myth, the oarfish has everything. 1, it has that freakish, unbelievable length.
Check. 2, it has that flowing bright red mane or crown.
Check. 3, it's super rare because it lives so deep.
Check. And 4, maybe the most important one. When people did see it, it was often sick or dying, washed up after a huge storm.
So its appearance seemed like a scary omen, a monster from the deep.
The perfect storm for a myth.
Okay, let's figure out the other part of its name. Oarfish. What's the story there?
Well, there are 2 great theories about that. The first one is the oar body theory.
Oar body?
Yeah, because its body is so long and flat, some people thought it looked like the gigantic flat wooden blade of an oar you'd use to row a boat.
Okay, I can see that. That makes sense. What's the other theory?
The second one is the oar fin theory. The oarfish has 2 very long, stringy fins on its belly. We call them pelvic fins, that just dangle down like long, thin strings.
And sailors thought.
They thought it used them to literally row itself through the water, like someone paddling a canoe.
That's such a funny image. A giant fish paddling with 2 little strings. But is it true? Did they row with them?
Ah, this is a great scientific detective story. For 200 years, everyone argued about it. Then in 2001, we got the first ever video of a healthy, living oarfish in the deep.
And what did the video show?
It proved they do not row with those fins at all. They just dangle there. But by then, the name oarfish had stuck.
So the name is based on a total misunderstanding. That's hilarious. Okay, let's file this amazing creature in the science library. Let's talk about its family tree, its taxonomy.
Right. Think of taxonomy like a giant address book for all life on Earth. And the really interesting part of the oarfish's address is its order.
Okay, what's its order?
It belongs to the order called lampriforms.
Lampriforms. That's a mouthful. What does it mean?
It's often translated as the shiny fish or shapes of light. And this is the oarfish's really weird extended family. They're all known for having extremely strange shapes.
So other fish in its family look nothing like the oarfish.
Exactly. Its most famous cousin is the opa, or the moonfish. The oarfish is long, like a ribbon. The opa is shaped like a giant, round, silver dinner plate.
No way. A ribbon and a dinner plate in the same family.
It's amazing, isn't it? One family, 2 totally different blueprints for being a giant.
So who are the oarfish's immediate siblings? Are there different kinds?
There are. We usually focus on 2 giants. First, Regalicus glesni, the one we call the original king of the herrings. It likes cooler ocean waters.
And the second one?
That's Regalicus russelli, or Russell's oarfish. This is the one famously connected to that doomsday fish legend in Japan. It prefers warmer tropical waters.
And you mentioned a tiny cousin that can zap you.
Oh, yes. There's a smaller relative called the streamer fish. It only gets to about 10 feet long, which is tiny for this family. And scientists who have handled it report that it can produce a mild electric shock.
So we have a real-life sea serpent that's longer than a bus, related to a giant silver dinner plate, and has a little cousin that can zap you. That's quite a family. All right, now that we know who the oarfish is, let's take a trip to where it lives. To get there, we have to go down the ocean's liquid skyscraper.
That's a great way to put it. The ocean isn't just one big pool of water. It's layered, like a building, and each floor has different rules for life.
Okay, so let's start at the top floor. That would be the sunlight zone, right? The epipelagic zone.
Exactly. That goes from the surface down to about 200 meters or 660 feet. This is the warm, bright, happy zone. All the plants live here. You find dolphins and tuna here.
And the oarfish.
The oarfish hates this layer. It only comes up here when it's very sick or dying. It's not his home.
Our journey takes us much deeper then, to layer 2, the oarfish's primary home. This is the twilight zone.
The mesopelagic zone. It goes from 200 meters all the way down to 1,000 meters. That's 3,300 feet below the surface.
The twilight zone. The name is perfect.
It is. Sunlight still reaches here, but it's really dim. Too dim for plants. It's this spooky, shadowy, blue-green world where it's always dusk.
And below that?
Below that, you hit layer 3, the midnight zone, starting at 1,000 meters. And that is total, perpetual darkness. Zero sunlight. The oarfish sometimes visits the top of this zone, but it really prefers the dim light of the twilight zone for hunting.
Okay, so living in the twilight zone sounds incredibly hard. The oarfish had to solve some enormous problems just to exist down there.
3 huge ones, really.
Mm.
Crushing pressure, freezing cold, and finding food in the dark.
Let's start with challenge 1, that crushing pressure.
Water is incredibly heavy. For every 33 feet you go down, the pressure increases dramatically. So down at the oarfish's home, at 1,000 meters, the pressure is 100 times stronger than what we feel up here.
100 times stronger? What does that even feel like?
It's like having a school bus, or maybe 10 full-sized elephants, standing on your head. Any creature built like us would be squashed flat instantly.
But how does the oarfish do it? Most fish have that little gas-filled balloon inside the swim bladder to help them float, but that would get crushed, wouldn't it?
It would be flattened into a tiny pancake.
Oh.
So the oarfish's solution is brilliant. Step 1, it has no swim bladder at all.
And step 2?
Step 2 is its entire body. It's built to be uncrushable. And that goes back to its watery, gelatinous body.
It's 96.5% water.
Exactly. It's basically a giant, very long bag of water. And if you think about it, you can't really crush a bottle that's filled all the way to the top with water. You can only crush one with air inside.
Ah, so the oarfish is the water bottle.
It's the water bottle. The pressure inside its body perfectly matches the huge pressure outside. So for the oarfish, it doesn't even feel it.
That's a genius piece of engineering. So the warm surface water is actually dangerous to it.
Absolutely. And that brings us to challenge 2, the deep freeze.
As you go down, the temperature drops fast, right?
It does. You hit a layer called the thermocline where it just plummets. Below that, the water stays at a constant near-freezing 4 degrees Celsius. That's 39 degrees Fahrenheit.
That's the temperature inside your refrigerator all the time.
All the time. And the oarfish is perfectly built for it. It's cold-blooded, so its body temperature just matches the water around it. It doesn't waste energy trying to stay warm.
So if it comes up to the surface, the warm water is like a fever. It makes it sick.
Very sick, very quickly. And finally, challenge 3, finding food in the dark. There are no plants down there.
Yeah.
So where does the energy, the food, come from?
It has to come from above, right?
It does. We call the food source marine snow.
Marine snow. That sounds so magical. What is it?
It's like a gentle, slow-motion blizzard that falls constantly from the sunny layers above. It's made of sinking bits of dead algae, dead plankton, and even the waste, the poop, from all the creatures living up in the sunlight.
So the deep sea is fed by a continuous shower of tiny edible leftovers.
That's a great way to put it. And this marine snow feeds the smallest creatures down there, like krill. And those tiny krill are the oarfish's absolute favorite food. Without this constant snow, the twilight zone would be an empty desert.
Now we get to look at the oarfish's body itself, its extreme blueprint. Let's start with that weird, jiggly, gelatinous flesh. We said it's 96.5% water, which sounds, well, a bit gross, but it's actually its greatest superpower.
It really is. That watery body solves 2 huge survival problems. The first one is buoyancy.
Okay, what does that mean for the fish?
Remember, it has no swim bladder. Its watery, low-density flesh makes it what we call neutrally buoyant. It just hangs there in the water, perfectly balanced without sinking and without floating up.
So it doesn't have to waste any energy just to keep from falling to the bottom.
Exactly. And that brings us to the second reason, energy saving. Food is scarce in the deep. Building a body full of dense muscle like a tuna has costs a lot of calories.
It's expensive.
Very expensive. But building a 30-foot body mostly out of water is scientifically cheap. The oarfish figured out how to be a giant without having to eat all the time.
It's the ultimate lazy genius. But if its body is mostly jelly, what keeps it from just flopping over or snapping in half?
That's where its skeleton comes in. Despite the watery body, the oarfish has incredibly strong bones along its spine. They're called hyperossified bones.
Hyperossified.
Hyper means extra, and ossified means bony. So extra bony bones. They act like internal scaffolding, like steel beams in a skyscraper, providing the support so its long body doesn't break.
Okay, now for the most amazing superpower of all, the detachable tail. This sounds like something out of a comic book.
It is one of the most astonishing facts about the oarfish. They can break off their own tails on purpose.
On purpose.
On purpose. It's a process called autotomy. It's the exact same trick a lizard uses to escape when a predator grabs its tail.
But a lizard just drops a tiny bit of tail. We're talking about a 30-foot fish. How could it survive losing like half of its body?
Because of another incredible anatomical secret. All of its vital organs, The heart, the stomach, the liver, the brain, they're all packed into the front 1/4 of its body.
Wait, only the front quarter? Seriously?
Seriously, the back 3/4 is mostly just spine and muscle. So if a shark grabs its tail, the oarfish can instantly snap a vertebrae, drop the entire back half, and swim away with everything it needs to live.
That is mind-blowing. It's the ultimate getaway plan. But here's the catch, right? The tail doesn't grow back.
It does not. And this explains the mystery of size. Scientists now think that almost every adult oarfish ever found on a beach was actually a broken fish.
A broken fish.
The one that measured 26 feet, it might have been 40 or 50 feet long before it had a close call and had to drop its tail.
So those 56-foot legends, they might actually be the true size of a complete healthy adult that we've just never seen.
It's entirely possible. The deep sea is still hiding its biggest secrets.
Let's talk about how it sees and thinks in the dark. First up, those giant eyes.
They're enormous, but they're not for seeing color. Think of them as giant light buckets.
Light buckets. I love
Their job is to catch every single tiny particle of light, every photon that filters down from the surface. In the dim twilight zone, you have to soak up every speck of light you can get.
And since it hangs vertically, it's looking up, right?
Exactly. It's designed to scan upward, looking for the dark silhouettes of its prey, the krill, against that faint blue light from above.
But while its eyes are giant, its brain is, well, famously small.
Incredibly small. After studying one, scientists found its brain is about the size of a pea. And get this, the brain is actually half the size of its own eyeball.
That's hilarious. A creature longer than a bus with a brain smaller than a pea. What does that tell us about it?
It tells us it doesn't rely on complex thought or problem solving. It runs on pure, ancient, deep-sea instinct. It just knows how to eat and how to hide.
So what about its other senses? How does it feel things it can't see?
It has a fantastic system called the lateral line. It's a series of sensitive organs that runs down the whole side of its body, and it lets the oarfish feel tiny vibrations and pressure changes in the water.
It's like a distance touch sense.
Perfectly put. It can sense a predator approaching or feel a swarm of krill moving long before its eyes can see anything. It's like having radar built into its skin.
And there was that great detective story about its nose.
Yes. For decades, scientists couldn't find its nostrils. They finally used X-ray scans.
And where were they?
They're inside its mouth, which means for the oarfish to smell the water for food, it has to swim with its mouth just slightly open. It sniffs the ocean through its mouth.
It's so interesting that a creature that inspired the scariest sea serpent legends is actually, well, a gentle giant.
It's a very gentle giant. It's what we call a filter feeder. Despite its enormous size, it eats the tiniest food in the ocean. It's very similar to how a huge blue whale eats tiny krill.
So what's on the menu for our silver ribbon?
Its main meal is krill, those tiny shrimp-like crustaceans, along with other small zooplankton.
And how do we know that for sure?
Because when scientists have studied stranded oarfish, they've looked inside their stomachs. And one stomach was packed with 10,000 individual krill.
10,000? For one dinner? How does it even catch that many tiny things when it has no teeth?
Its mouth is small and completely toothless. It's built for sucking and straining. It has what we call a protrusible jaw.
Protrusible?
It means it can shoot its jaw forward like a tube, like the hose on a vacuum cleaner. It just swims up to a cloud of krill, opens its mouth, and sucks in a huge gulp of krill-filled water.
A deep-sea vacuum cleaner? But how does it keep the krill and get rid of the water?
That's the genius part. Inside its mouth are these long, comb-like structures called gill rakers. They act exactly like a pasta strainer. They trap the thousands of krill inside while letting all the water escape through its gills.
It has a built-in pasta strainer. That's so cool. Okay, so let's talk about how it moves. It doesn't swim like a normal fish, does it?
No, not at all. Its movement is called ambiform swimming. It's very unique. The oarfish keeps its long 30-foot body perfectly straight and still.
Perfectly straight.
Perfectly straight. It moves forward by sending these high-speed, graceful, rippling waves down its single, long dorsal fin. It looks like a ribbon fluttering in the wind.
So it's more of an expert floater than a powerful swimmer.
Exactly. It's built for precision and stealth, not speed. And that leads us to the most fascinating discovery about it. Its favorite hunting posture.
The one the deep-sea robots caught on camera.
That's the one. It hangs vertically in the water. Head up, tail down, like a giant silver stick.
Why on earth would it do that?
It's a brilliant strategy for hunting and hiding at the same time. Let's start with the hunting advantage. By hanging vertically, its giant light bucket eyes are pointing straight up.
So it can scan the dim light above it?
Looking for the dark silhouettes of krill clouds. It just silently glides straight up into its meal.
And the hiding advantage. How does a 30-foot silver ribbon hide?
By making yourself as thin as possible. By hanging vertically, it presents the smallest possible target to a big predator, like a shark, looking up from below. Plus, its shiny skin reflects the darkness, so it almost disappears.
So it just waits patiently, letting the food come to it. This brings up the diel vertical migration, right? The biggest commute on Earth.
It is. Every single night, trillions of creatures, krill, squid, small fish, all swim thousands of feet up to the surface to feed. Then every morning, they swim all the way back down to the dark to hide.
That sounds exhausting. Does the oarfish join in?
No. And that's the oarfish's lazy genius.
Yeah.
It's a weak swimmer. It's not built for marathons, so its strategy is smarter.
What's the strategy?
It stays right where it is, in the twilight zone. And the entire buffet, the entire migration of krill, swims right past its mouth twice a day.
Once on the way up and once on the way down.
It's the most energy-efficient hunter in the deep sea. It just waits for dinner to be delivered.
You know, the oarfish doesn't just have that old sea serpent myth. It has a modern, even spookier reputation, especially in Japan.
It does. There, the oarfish is called Ryugu no Tsukai.
Which means?
It translates to the messenger from the sea god's palace.
That sounds beautiful, but the legend is actually kind of scary, isn't it?
It is. The story says this fish only comes to the surface when the sea god is angry or when the earth itself is shaking. So seeing one is a warning of an earthquake or a tsunami.
Which is why people call it the doomsday fish.
Exactly. And this myth became really famous after the huge 2011 earthquake in Japan because people remembered seeing oarfish wash ashore in the years before.
That is a very spooky connection.
It is, but science doesn't trust spooky coincidences. It demands proof. So in 2019, Japanese scientists did a massive amount of detective work.
What did they do?
They compared decades of oarfish sightings against decades of major earthquake data. They wanted to see if the fish really did predict the quakes.
So what was the verdict?
The myth is busted. They found no connection at all.
No connection.
None. There were thousands of earthquakes with no oarfish warnings, and oarfish surfaced when nothing happened. They concluded it was just a frightening coincidence.
So what's the real reason they wash ashore?
It's usually much sadder. The oarfish is sick or injured or was just pushed up to the surface by very powerful deep-sea storm currents.
And once they're at the surface, the warm water and low pressure are deadly for them.
Exactly. They're too weak or confused to get back down to their safe, high-pressure home.
But there is one idea scientists are still checking, right, about what happens before a quake.
There is. Could plate shifting on the seafloor release weird chemicals or change the electricity in the water? The theory is that this might cause the oarfish to flee its habitat in a panic.
So it's not a magical warning, it's just them running away from something that feels wrong.
Precisely. It's not proven, but it's a much more plausible scientific idea.
Okay, moving from myths to mysteries. Their family life. The oarfish life cycle is basically a big black box, isn't it?
A huge black box. We know almost nothing because they are so solitary and live so deep. We have to rely on clues, like detectives.
So what clues do we have about baby oarfish?
We know they are oviparous, which means they lay eggs. And they are likely broadcast spawners.
Broadcast spawners.
Think of them like a giant confetti party in the ocean. They just release thousands of eggs and sperm into the water, hoping they find each other. There's no parenting at all.
And where do the fertilized eggs go? Do they sink?
Actually, they do the opposite. The eggs are pelagic, which means they're buoyant. They float
Up to the sunlight zone.
all the way up to the sunlight zone. They hatch there after about 3 weeks, and the tiny larvae live near the surface where food is easy to find before they get bigger and descend to the deep.
Which brings us to an incredible moment of discovery. The 2019 Okinawa miracle. This is where humans finally tried to raise a baby oarfish.
It was a brilliant, spontaneous experiment. Scientists in Japan found a freshly dead male and female oarfish. They knew they might never get this chance again
So they rushed them to the lab.
and performed artificial insemination. They mixed the eggs and sperm in a dish. It was the first time this was ever tried.
And did it work? Did they create baby oarfish?
They did. After 18 days, 19 tiny larvae hatched. They looked like miniature adults, but they swam really strangely, sort of downward facing.
That's an incredible victory. So what happened next? What did they learn?
Well, this is the tragic but incredibly important part of the story. The scientists offered them standard baby fish food, tiny things like rotifers and brine shrimp.
Oh.
The larvae refused to eat any of it.
Oh, no.
They survived for 4 days, on the tiny bit of yolk left from their egg, and then they died of starvation.
That's so sad.
It is, but it was also a massive scientific success. That failure proved that oarfish larvae are extremely picky eaters. They require a specific unknown food source to survive. And finding out what that food is, well, that's now one of the ocean's greatest secrets.
Wow. It's just so clear that the oarfish is one of the most mysterious creatures out there. We've solved the sea serpent myth, but we still have this huge list of things we just don't know.
The fact that we have so many unanswered questions about the world's longest bony fish just shows how much is left to explore in the deep sea.
Let's talk about those big puzzles. Mystery number 1, the true lifespan. How long does this gentle giant actually live?
We have no idea.
None.
We don't know. Usually, scientists figure out a fish's age by counting the growth rings on its otoliths. They're like tiny ear bones. It's like counting the rings on a tree.
Right.
But the oarfish skeleton is so low calcium, so gelatinous, they seem to have no visible growth rings at all. So we have no way of knowing if they live for 10 years, 50 years, or 100 years.
They're ageless ghosts. Okay, mystery number 2, going back to its looks. The red crest's purpose. Why does it have that spectacular red crown?
Again, we don't know for sure. It's almost always broken when they wash ashore, so we've never seen a healthy one use it. But we have some fun ideas.
Like what?
Well, is it for mating displays, waving a bright red flag in the dark to attract a partner? Is it sensory, helping them feel the water? Or maybe, since red light doesn't travel well underwater, it just looks black, maybe it's a form of invisibility cloak.
An invisibility cloak. I like that one. And what about the fins the fish is named for? The oar fins.
That's mystery number 3. We know they don't row with them, so what do?
What's the best guess?
The strongest idea is that they're sensory antennas. They dangle down below the fish while it's hovering, letting it taste or feel for chemical signals or vibrations in the dark water beneath it.
So it could be sensing a mate or a predator hiding below.
Exactly.
And mystery number 4 is less about its body and more about its lifestyle. The deep sea blind date.
This is a huge, challenging question. The twilight zone is massive and pitch black.
Mm.
How do two solitary loners find each other in that enormous space when it's time to breed?
Right. You can't just put up a sign that says, oarfish looking for date.
You can't. So do they release powerful chemicals called pheromones that travel for miles through the water? Do they all migrate to a secret breeding spot? It's a total mystery.
And to solve these mysteries, we can't just go down there ourselves. We have to send robot explorers.
We do. We need technology that can handle the crushing pressure and the total darkness.
So let's talk about the robotic eyes of the scientist.
Sure.
What are the main tools we use?
The first is the ROV, a remotely operated vehicle. Think of it as a robot on a long string.
On a leash.
Exactly. It's connected to a ship by a big, strong cable. Scientists stay safe on the ship and fly the robot with a joystick, watching what it sees on HD screens.
And it was an ROV that got that first ever footage of a healthy oarfish hanging vertically, right?
That's right. Then you have the AUV, or Autonomous Underwater Vehicle. This is the Smart Robot Torpedo.
So no string on this one.
No string. Scientists pre-program a mission, drop it in the water, and it swims completely on its own for days or weeks, gathering data before it comes back.
And finally, there's a new tool that is so advanced you don't even have to see the fish.
That's eDNA, environmental DNA. This is a huge step forward. Every creature sheds tiny bits of its DNA into the water, just like you shed skin cells or hair.
So the oarfish leaves behind a DNA blueprint trail wherever it goes.
It does. So scientists can just collect a bottle of seawater from the twilight zone, take it to a lab, and test it for the oarfish's unique DNA.
That's incredible. You can prove an oarfish was there without ever seeing it. How does that help solve the mysteries?
It helps us create an accurate map of where oarfish live all over the world. And that could be crucial for solving that deep-sea blind date mystery by showing us potential migration routes or secret breeding areas.
So before we wrap up, we have an important question. Since the oarfish is so rare, you would think it's in terrible danger. Is the king of the herrings endangered?
This is one of the happiest parts of the story. The good news is that the oarfish is listed as least concern by the IUCN Red List.
That's the best, safest status you can have.
It is.
But why is it so safe if it's so rare?
2 main reasons. First, it lives in almost all the world's deep oceans. It's very widespread. And second, and this is the most important part, humans don't hunt it.
Because of that jelly-like body.
Exactly. Its meat is gelatinous and completely inedible to us. Since it has no value to fisheries and lives deep, we leave it alone. Its strange body is its greatest protection.
So it's safe from fishing nets. But there's a warning here, isn't there? Just because it isn't hunted doesn't mean it's safe.
Right. It's a messenger from the deep, warning us about the invisible threats we're sending down to its hidden world.
Let's talk about the 3 biggest invisible threats. First up, microplastics, the plastic soup.
The oarfish is a filter feeder. It sucks in water and strains out krill. But as plastic pollution breaks down into tiny microscopic pieces, the oarfish can't tell the difference between a krill and a piece of plastic.
So it eats the plastic.
Or the krill eat the plastic, and then the oarfish eats the krill. Either way, the plastic builds up inside its body over time. It's called bioaccumulation. It's being poisoned from the inside out.
That's terrible. Okay, threat number 2, ocean acidification, the acid bath.
When we put too much carbon dioxide in the air, the ocean absorbs it. This makes the ocean water more acidic.
Yeah.
And that is very dangerous for any creature with a shell.
And the oarfish's entire food source is krill, which are tiny crustaceans with shells.
Exactly. If the ocean gets too acidic, the krill start to disappear. And if the krill disappear, the oarfish will starve. It's a chain reaction that starts high up in the atmosphere and ends 3,000 feet down in the dark.
And finally, the newest and maybe scariest threat, deep sea mining.
Companies want to use giant robots to scrape valuable minerals off the deep sea floor for things like batteries. The problem is these robots kick up enormous clouds of mud. We call them sediment plumes.
And what does that mud cloud do?
It travels for miles through the water. And for a filter feeder like the oarfish, that thick, muddy water gets sucked into its mouth and clogs its gill rakers.
It clogs its pasta strainer.
It clogs the pasta strainer. And if it can't strain out its food, it will choke on the mud and starve. This one activity could be catastrophic for the entire food web of the Twilight Zone.
Wow. What an incredible journey we've taken today. We went from these terrifying tales told by sailors centuries ago all the way to the cutting-edge science of deep-sea robots. We started with a sea monster and discovered the true oarfish.
The world's longest bony fish, a ribbon of silver and red. We learned how it uses its gelatinous body to defeat crushing pressure, how it can drop its tail to escape a shark, and how it waits patiently for the krill buffet to swim by.
And we explored all the great mysteries that are still left, that we don't know its age or what its babies eat, and that busted myth about it predicting earthquakes. Thank you so much for coming on this incredible expedition with us.
The oarfish really is an ambassador for a hidden kingdom. It teaches us that the world's most mysterious monsters aren't hiding on other planets. They're living right here in our own oceans, thousands of feet below us.
It's a messenger, but not of doom. It's a messenger of discovery. Its survival depends on us protecting a world we can't even see. Every time we choose to use less plastic or we just choose to learn more about the deep, we are helping the king of the herrings keep his mysterious kingdom safe.
So as you go about your week, think about this. When you see a deep-sea creature, remember you're looking at an animal that has solved 3 enormous problems: pressure, cold, and darkness, that we need expensive, strong metal robots just to witness. The natural world is full of these amazing biological blueprints, just waiting for us to discover them.
See you next time on Saltwater Stories.